Alrighty, so here's a quick review of Unit 2. So the first thing we started with in Unit 2 is functions. And what is a function? Well, a function is when every input for an equation, a graph, a table, etc., has exactly one output. Okay? And the exactly one is the important part there. It can really and truly only have one number that it matches with. Okay? And it doesn't go the other way. We don't care if the output has more than one input. So it gets kind of confusing. It's easier just to show you with a visual. So up here at the top says, is the example a function? And the answer was no. So let's see why. If you look over here at the list of coordinates, we see that the 0 x value is with -1, but then again the 0 x value is with +1. That is bad. Okay, the fact that the 0 has two different y values is not okay. Here's that same thing in the table. We see 0 is listed with -1 and it's listed with +1. Not okay. Again, over here in the mapping, we see Mr. 0 here, but there's two arrows. That's not okay. I often tell my students that this left-hand bubble in the mapping is a whole bunch of boys. Okay, this is their top hat. And they are calling a bunch of girls to ask them to prom. Okay, here's all the girls. So Mr. 0 here is calling Miss -1 and asking her to prom. He's also turning around and calling Miss +1. That's not okay. He can only take one girl to prom, right? Like Mr. 4 down here, he's behaving. He's only calling 0 and that's it. That's great. Alrighty. You can also see it in the graph using the vertical line test. If you move a vertical line or you draw vertical lines, you should only have 1 point on each vertical line. For example, we only have 1 point there. That's good. However, when I draw a vertical line here, I see these 2 points and that is bad. This does not pass the vertical line test, so it means it's not a function. Okay? So here's an example of something that is a function. The answer is yes, this is a function. Okay? When I look through my list, I see that every input only has one output listed. Same in my table, same in my mapping. All these boys are only calling one girl and asking them to prom. Okay? Now, this is also an example of how it doesn't work the other way. So for example here, this -2 is being asked by 2 boys. 2 boys are calling -2. Although that doesn't match this list, but that's okay. It doesn't matter. It's still a good example. Or we can just look down here at 3. This does match. The 3 here is being called by 4 and by 6. You can see it over here in the table as well. There's the 3 being called by 4 and 6, and that's okay. It is not her fault that she got called by 2 boys. Now, hopefully she turns somebody down, but if not, that's okay. She doesn't have to have only one arrow. It's the boys, it's the X's, the inputs that we care about, okay? You can see this graph also passes the vertical line test. There's only 1 point on each vertical line, and that's good. So that is a function, okay? So now, another thing we talked about in Unit 2 was evaluating functions, plugging numbers in. So if you see this top problem, we've got a -2 in where the x normally is. So I would read this as g of x equals blah, blah, blah. But now I'm reading it as g of -2. That means I'm just going to plug in a -2 everywhere I see an x. So I just need to do the PEMDAS. Now, you can use your calculator. Just make sure you type everything in exactly as you see it. You could also use the table menu in your calculator. Either way, doesn't matter, but I'm going to get 4 plus 6 plus 2. My answer would be 12. You might also see it written like the second problem, where it says if a function is defined by f of x equals x squared minus 5, and the domain is blah, 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 what are the dependent values? We have to just kind of think about the synonyms for these things. Domain refers to x, dependent refers to y. So they're saying plug these in for x and see what you get for y. So that means you're going to have 3 answers here. I'm going to plug in 2, I'm going to plug in 5, and I'm going to plug in 8. Because all of those are listed as my domain, so that means I have 3 different x values. So this would be -1, it'd be 20, and it would be 59. So those would be my 3 answers for this problem. Okay, another thing we talked about in Unit 2 is domain and range. With domain and range, you have 2 different types of data. You have discrete data, which is just listed points, or in a graph, it's just a scatter plot, or you might have continuous data. Okay, and that's when you have a graph that's connected, right? It's a smooth curve or a line, but it's connected. It's not individual points. Or it could be an equation, okay? So really quickly, I'm just going to do a couple of these. If you're giving discrete data, that's where you just list out the individual numbers, okay? So for this mapping, for example, the domain would be 8, 9, 10, 13. My range would be negative 3. These are not in order. Negative 1, sorry, and 5. Okay, so again, you usually want to write them from least to greatest. Every now and then you won't see it written that way, but you should. And you only want to list things twice. So even though there's 2 arrows coming in here at negative 1, we still only list the number once. So when I did the domain and range for this table, I would want to make sure this 3 was only listed once in my domain and range. Okay, but each of these are going to have lists for their domain and range. Okay, so for example, the graph, I'd go and I'd look at all these individual x values that are being used. So I would write 82, 84, 86. I'm not going to write it twice, even though there's 2 points on 86, 87, and I'd go on and on. Okay, but now let's talk about continuous data. Continuous data is when you're going to want to use your inequality symbols. So if I wanted to do the domain of this graph on the left, and I wanted to list them out, right? I want to list out each number individually. So I'd write negative 6. Then I'd have to write negative 5.9999999 because there's an infinite number of points along this curve. But obviously that would not work. It would take me way too long. So here's where I do an inequality instead. So my domain is all the points from negative 6 all the way to 7. Now, this closed circle means I put a less than or equal to. The open circle means I just put less than. The range, that one's going to be from bottom to top. So I'm going to start at the bottom of my graph and look up. Negative 8 is the first number I come to. I go all the way up to the very top of the graph, which is at the 4. Notice I do not just stop at the other point. I go all the way up to the very top of the graph. Okay? This middle graph is an example where we have arrows. When you have arrows, that implies that it goes on and on and on. So the domain here is actually going to be all real numbers because this is going to forever head to the left and forever head to the right. Same with the range, all real numbers, forever down, forever up. Okay, and the equation is a little bit different. First of all, you could graph this in your calculator and see what it looks like. If you'll remember, this looks like y equals mx plus b, so this is just going to be a line. Okay, you could also graph it by hand. It's got a y-intercept of 1, a slope of 2. It's going to look something like that. Well, again, domain is going to be all real numbers. Range is going to be all real numbers. Okay? Now, the last thing we talked about in Unit 2 was domain and range of situations, and this is what caused people the most grief. But just remember that it's the same idea. You're wanting to list out all of the x values, and you're wanting to list out all of the y values. Okay? It just so happens with the word problem that you're limited. So this problem is from a star. It says the daily cost of hiring a plumber Y to work X hours on a repair project can be modeled using a linear function. Right here, it tells you what Y and X stand for. So X is hours. Okay, so that means my domain has to do with the hours. The range says Y, the daily cost. Okay. Okay, so the plumber charges a fixed cost of $80 plus an additional cost of $45 per hour. The plumber works a maximum of 8 hours per day. For 1 day of work, what is the range of the function for the situation? Okay, so we're wanting the range. First of all, just that alone, I can look at my answer choices and get rid of A because that says X and C because it says X. So now I'm just basing it off of B and D. I need to decide which one has the correct minimum number here and which one has the correct maximum number. Well, it says that he works a maximum of 8 hours a day. Well, if I know the equation that they gave me is a fixed cost of 80 plus 45 per hour, and he can only work 8 hours, well, let me just plug an 8 in there and see what the maximum number would be. 80 plus 45 times those 8 hours. So that'd be 80 plus 360. Is that right? I should probably work that out to make sure. 40, yeah, 360. So add those together. Oops, and we get $440. So that's going to be the maximum amount that he could make in a day. Well, looking at my answer choices, that means B would have to be my answer. Okay, so these problems are less about looking at a graph and going from left to right, and it's more about just making sure you understand what domain and range mean. Range means the Y values. So in this case, it meant the costs. What are the types of costs that he could earn? Okay. Just take these problems slow, read them, read it again, skip it, come back to it. Just take them slow, and I bet you'll understand it more than you realize. Just don't try to do it quickly because that's what tends to mess people up.